Welcome friends. In this video, I will discuss a problem number 6, which was asked in ISI UGB 2023 for B.Stat B.Math admission test conducted by ISI, that is Indian Statistical Institute. Problem is regarding sequence and inequality. What is the problem? Let un be a sequence of real numbers defined by u1 equal to 1 and un plus 1 equal to un plus 1 upon un for all n greater equal to 1. Prove that un less equal to 3 square root of n upon 2 for all n. Un is defined by the recursive relation un plus 1 equal to un plus 1 upon un for all n greater equal to 1 and u1 equal to 1 for un equal to 1 for n equal to 1. We see that u1 plus 1 equal to u1 plus 1 upon u1 equal to 1 plus 1 upon 1 equal to 1 plus 1 equal to 2. So u1 is positive and u2 is also positive. This motivates us to define un is positive for all n greater equal to 1 and also un greater equal to 1 for all n greater equal to 1. Let Pn be the statement denoted by un less equal to 3 square root of n upon 2 for all n greater equal to 1. We use mathematical induction to prove the result. u1 equal to 1, therefore u1 equal to 1 which is less than 3 by 2 which is equal to 3 square root of 1 upon 2. This shows that p1 is true. That is, pn is true for n equal to 1. That is, we complete the basic step of induction. Let pk be true for k greater than 1. This is the induction hypothesis. That is, uk less equal to 3 square root of k upon 2 and we call it number 1. Induction step. We have to prove that pk plus 1 is true. That is, uk plus 1 should be less equal to 3 square root of k plus 1 upon 2. If not, Let if possible uk plus 1 greater than 3 square root of k plus 1 upon 2. Then uk plus 1 upon uk by inductive definition of uk plus 1, which is greater than 3 square root of k plus 1 by 2. Simplifying we have, and using the fact uk greater than 0, we have this, and this implies that uk plus 1 whole square minus 3 square root of k plus 1 upon 2 times uk plus 1 greater than 0, and this gives by simple calculation, which implies that uk minus 3 square root of k plus 1 upon 4 whole square minus 9 times k plus 1 upon 16 minus 1 greater than 0, which implies that uk minus 3 square root of k plus 1 upon 4 whole square minus 9k plus into k plus 1 upon 16 minus 1, which is greater than 0. Using a square minus b square equal to a plus b into a minus b, we have this inequality. This gives here we use the fact x minus a into x minus b greater than 0 if and only if x less than minimum of ab or x greater than max of ab. Now square root of 9k plus 1 plus square root of 9k minus 7 by 4 greater than square root of 9k plus 9 minus square root of 9k minus 7 by 4. Therefore, we have or when uk less than square root of 9k plus 9 minus square root of 9k minus 7 upon 4, then we have uk less than square root of 9k minus square root of 9k minus 7 into square root of 9k plus 9 plus square root of 9k minus 7 upon 4 times square root of 9k plus 9 plus square root of 9k minus 7, which gives uk less than 2 upon square root of 9k minus 7. Now, k greater than 1 implies that k greater equal to 2 implies that 9k greater equal to 18 implies that 9k minus 7 greater equal to 11, which is greater than 4, which implies that 9k minus 7 square root of this thing greater than square root of 4 equal to 2, which implies that 1 greater than 2 upon square root of 9k minus 7, that is 2 upon square root of 9k minus 7 be less than 1. And since uk greater than equal to 1, so this is a contradiction. So uk less than square root of 9k plus 9 minus square root of 9k minus 7 upon 4. This is not true. So when uk greater than square root of 9k plus 9 plus square root of 9k minus 7 upon 4, then we have by induction hypothesis. This gives this gives have using a plus b whole square equal to a square plus 2ab plus b square. This gives this gives this gives so we have square root of 9k plus 9 into square root of 9k minus 7 less than 9k minus 1. Squaring both sides we get this gives 36a less than 64, which implies that a less than 64 by 36 equal to 16 by 9 less than 2. Since k is an integer, therefore k equal to 1. Again, we arrive at a contradiction. And this contradiction is due to our wrong assumption that pk plus 1 is not true. Whenever we assume that pk is true, so we must have pk plus 1 is true whenever pk is assumed to be true. So we have proved the result. Induction step is complete, and we proved the result by induction. Thank you for watching this video.